Hey everyone! Okay, so I guess we can start. Just let me know in the chat if you can hear me. I think you should be able to hear me. You know what, I'm going to actually, as usual, test it on YouTube. Yes, it seems to work. If you could let me know actually if it works like well, or if it's too loud, or if it's just right. It's terrible. Okay, so I'm going to like do this. Is it better now? Let me actually double check it. One, two, three, four. Yeah, that's really weird. It's actually, you know, the microphone I'm always using, so it's pretty weird that it's not working correctly. How about now then? Can you tell me if it works now? Seems to be better, at least in my case. I'm just going to do L2 louder and then we can go, I guess. Okay, and my moderator is ready as well, so let's just go. Perfect. This is actually the loudest I can go, so let's keep it at this. And if the sound quality like decreases during my stream, just let me know. So okay, hey everyone, officially now. Welcome back to my streams actually, since I didn't do one for like, I don't know, 3 months or something. But yeah, it's time to go back. Actually, I didn't do it because I was working on this. This is like my second book in Polish. Actually, it's not only mine, there are like 12 authors. And but I handled like, you know, the process from like gathering the authors to actually like working with them to complete their articles and editing them. And a couple of other people also have, like Mateusz Jurczyk did a great job on editing. There's also like Tomasz Łopuszański, who's like usually he's an editor of one of the Polish magazines about programming, and he also helped on this book. And a few other people, like my moderator, for example, also did some proofreading. So the project took basically like most of the year, therefore I didn't have too much time, and the other reason is that I also helped with a conference. But all in all, you know, it actually seemed to work fine in the end, and I did complete the project, which means I can do some CTF streaming right now. Yeah, so, you know, once the book was finished, we actually had a nice, like, meeting with the audience of the book, with the readers. So yeah, these are like most of the authors, not all of them though. You might know, like, if you're playing CTFs, you might know this guy. He's like Redford from Dragon Sector. This is Mateusz Juru from Dragon Sector. I think this guy is playing for Delicious Horse, and this guy as well. This is Mac from Dragon Sector, Jagger from Dragon Sector. I think this guy is also playing with Delicious Horse CTF team, and this is Katie from Dragon Sector. So basically, like, CTF people writing a book on reverse engineering. Yeah, but also as a conference, as I mentioned, the conference looked like this. Actually, a lot of people came. It was the first edition in Poland. We're probably going to make well, another one next year. We'll see how it goes though. So yeah, but I'm back, so we can do some CTFs. Before I get into that, a couple of shoutouts. So first of all, shout out to KrzaQ, which is my moderator today, and this is his website, dev.krzaQ.cc. He writes mostly on C++, and he's really good in C++, so it's worth reading his blog. Another thing is, another person actually is Life Overflow. It's a person I spotted yesterday on Reddit, and he's like, he has this awesome YouTube channel with also CTF stuff and introduction into security, but it's really technical, and like he goes into like heap exploitation and so on, so that's not like your daily basics. I really recommend it, so yeah, take a look. Apart from that, well, you know my blog, and this is the picoCTF, well, website, 2013, so it's like 3 years old now, almost 4 years old, I guess, soon. It was created, well, the CTF was, as I mentioned in the description of the stream, it's like an entry-level CTF, which means that it was created for high school students, which means the challenges are easy. The challenges are like entry-level for beginners. So if you're here to learn like what CTFs are about and how to solve super basic tasks and how to get into it, how to start, well, you came to the right place, basically. Do not expect like super hard Pwn 500 challenges. These take like 20 hours to solve anyway, so they wouldn't fit a stream. So I actually hope I can do quite a lot of challenges today, live. And yeah, so let's just start, let's get going. Expect that the first challenges, until I get like to like 100 points per challenge, are going to be like super easy. Like before I open the challenge, I know the flag. Well, maybe not that easy, but they will be easy. So yeah, let me maybe make it a little bigger. So what's lagging? Video keeps freezing. Is it like the whole video, or is the sound okay? That's the most important part. Is the sound okay? Because I cannot do too much actually if the streaming is freezing for some reason. But if the sound is okay, then the desktop doesn't have to be 20 FPS and so on. So just let me know. Worst case scenario, the recording should be okay. So yeah, let me know if the sound is okay, and then we can go actually, yeah, you know what, I'm going to check. No, it is freezing. Okay, YouTube, what the hell? Yeah, okay, let's, oh, maybe it just froze, so yeah, try to restart the stream. So be right back. Okay, please let me know if everything is up now and if everything works. Yeah, turning it off and on again is the best solution possible. So it did work for me, at least on the preview I can see that it goes smoothly again, so yeah, let me know if there are any more problems. And I'm just going to tell like everyone, just like... okay. So, all fine. Okay, KrzaQ says that it seems to be working now, so yeah, let's just continue. Worst case scenario, there's always a recording, which, I'd prefer to do live but yeah, for you guys, but whatever works. So the first challenge is failure to boot. Now, I'm already signed into the CTF, anyway, okay. After opening the robot's front panel and looking inside, so the theme basically of picoCTF or picoCTF is like robots, like this kind of robots, toaster robots from space or something. Yeah. Okay. So yeah, failure to boot. After opening the front panel, you discover a small red button behind a tangle of wires. Pressing the button lights up the robot's primer screen. It glows black and quickly flashes blue, and line of a small text types out. Error 23. The text refreshes and displays the prompt. File system recovery initiated. File system could not be identified. Please enter file system format. Please enter. Okay, that's a funny one. It might be helpful to Google the error. Okay, let's Google the error. Okay, so it's fat. Oh, there are solutions for it, but okay. Yeah. Oh, that's actually in Polish. Can I translate it? No, I cannot translate it to English, but yeah, fat file system. Let's see if I can just type fat here. Yeah, it's correct. So this should give me access to more challenges. And there are more challenges, so we can continue. Read the manual. Let's start with this one. On the back of the broken panel, you see a manual, and it's a text file actually, and it is a text file, and it looks encrypted. You need to find the emergency repair K in order to put the robot into automatic blah blah blah. It's using okay. So they even disclose the cipher here, so that's why I said it's an entry-level CTF. So Caesar's cipher is just rotating the bits. So the fastest way basically to solve it is, you know, to just like find a website on the internet which does it. That's the fastest way, and that's what I usually do on the on the CTF challenges. So let's do it like this, like rot3. That's actually the cipher. The Caesar cipher is rot3, which means rotate, like change A to, you know, D, B to E, and so on and so on. And there is this, but this just accepts a small text, and I want a large text. Yeah, I'm going to copy this. I'm going to put it here, and I'm going to decrypt it. So actually, encrypting and encrypting is almost the same stuff, but you know, it's like the opposite. So this should be it. No. This one? No. But usually is a side which, you know, just maybe this one. So actually what I'm looking for is the rot3 is this, or maybe it's the rot13 actually. Maybe I'm just like making stuff up. But rot13, no, that's not Caesar's cipher. This site, if I remembered correctly, just shows, you know, like decrypted everything. And instruction manual is rot18. Yeah. Okay, yeah. To enter automatic recovery mode, enter the following key, and this is the key. I don't know if you see it correctly. Let me just like zoom it a little. Yeah, so in the end I needed to select rot18, and I used this random website on the internet which I just found by googling to, it displays like all the rots, like uses all the keys. This is actually the key for the cipher, it's not like too good as you can see. And yeah, and this is the only string which makes sense, instruction manual for something, the other is like gibberish. So yeah, I can copy this, and this should be the flag here. So yeah, that's correct, and it's solved. Then we have this one. The book has instructions on how to dump the corrupted configuration file from the robot's memory. You find a corrupted XML file, and you are looking for a configuration. Okay, so yeah, so if I open, you know, XML in Chrome, it tries to check if it's valid, but I don't care. I'm going to display the source code. Sorry, I'm actually going to change the language of Chrome for like next stream. And yeah, so I displayed the source code, and there is already the super secret flag here. So yeah, as I said, entry level CTF. That's it. Just like opening the task, and that's done. That's good to, you know, to get started. If you've never done this sort of stuff, it's good to do these kind of challenges. Next challenge. The spaceport technician waves to you, and you approach him. Well, that escalated quickly. I was fixing a robot, and now a space technician is waving to me. Okay. He tells you that he noticed you walking around suspiciously. No, no way. Me never. No. He adds that he knows the door code and is willing to give it. I mean, who's the suspicious person here? Come on. And is willing to give it to you for answering a small trivia question. For what kind of car was the first? What? For what kind of car was the first unlocked iPhone traded? Okay, so I don't know. My guess is like some Porsche or something, but let's just look it up. Unlocked first unlocked iPhone traded for car. Let's just do some googling. Teen trades first unlocked iPhone for Nissan, and I guess this is our. Oh, and teen is of course George Hotz, is it? Blah, blah, blah. Yeah, George Hotz, obviously. If you don't know, George Hotz is like, it's GeoHot, and he's also was playing CTFs at some point, and he was doing really, really good. I mean, he's like a really smart and awesome player. Okay, that's correct. So cool, we can now go forward. Grep is your friend. After plugging the robot into the computer, so I don't know why we approached some technicians, but I don't follow the story, but okay. Yeah, like usually CTFs don't have a story anyway, just have a common theme. After plugging the robot into the computer, the robot asks for the name of a file containing the string secret of code. You can find it using command line interface. So the problem is that I cannot log in actually to picoCTF shell. So you know there's this stub shell, but if I use my credentials, yeah, it doesn't work. I tried like a lot of times before, and I tried even with like with a normal shell client, like SSH client, and no luck. So this is actually unsolvable for me due to the reasons I cannot like enter this. So I'm going just to continue. Yeah, sorry, just chatting with the moderator. Okay, you notice... Oh, there's a pickup file. Okay, so this doesn't require a shell, just checking. You notice the indicator light near the robots, blah, 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 blah. Perhaps the robot is connecting to a network using Wireshark. You are able to create a pickup file. So a pickup file is a network dump. If you don't know, you probably know by now. You suspect the robot is communicating with crashed ship. Your goal is to find the location of the ship inspecting network traffic. You can perform, or you can download the pickup file. Yeah, I'm going to download the pickup file. I'm going to open it in Wireshark. So yeah, Wireshark is opening, and I have, it seems I need to update it. And there are not a lot of packets. There are like, I don't know, let me maybe make it a little bigger. 33 packets, and it's trying to, looks like it's a TCP stream, so I can just right click and select follow TCP stream, and it will display me this window, which you don't see, but you should see it now. And this is the communication. Like red is everything marked in red or highlighted in red is actually one point of a communication, one node of a communication, and everything blue is the other. So let's see what they say here. Coordinates, this is what we are looking for. Yeah, so just, you know, scan it for coordinates. I'm not closing it yet, just if it doesn't work. No, it's okay. I was wondering if I should put it, you know, into Google Maps or something to, maybe there's some location where like Eiffel Tower or whatnot, and I should enter Eiffel Tower, but it seems that's not the case. You say HKR is saying I can download. Oh, I can download the file. Thank you. I didn't notice that I can download the file here, so we can actually solve this challenge, which is great. Thank you. HKR. I don't know how to read your nick. I did download the file, therefore I need to copy it to the correct location, and I need to unpack it. No, I can actually unpack it on stream. So I'm going to launch this is my Windows console, sorry, my Linux console, and as I mentioned if you did watch the previous streams, you know that I'm using Windows 10, but I actually have a Linux virtual machine running, which has access to my Windows drives, therefore I can quickly span a Linux console, which has sees my Windows drives where I just downloaded this file. So I'm going to I'm going to untar it, and it put every file in this directory. Well, that's not great. Does every file start with AF? That's actually good. I'm going to, make a directory now called G, and I'm going to move all the F files there. Yeah, that's better. Okay. Now, what am I looking for? I'm looking for secret of code. Well, this is going to be easy, I'm just going to do rgrep and this. Rgrep is just recursive grep. and this is the file. And what's the answer to this? Is it the name of a file? Yeah, it's the name of a file, so I'm just going to copy this. You probably noticed that this looks like a base 64 string, right? But that doesn't matter for this task. So yeah, now selecting the text is hard. Yeah, so this is solved. Again, thank you for pointing out that I can actually download the files. I didn't notice that. Next, get key. There's bound to be a key on the Spaceport's hidden website. So the first web challenge, get key. Enter either your aren't admin or wrong competition. Okay. Again, let's start with looking at the source code. This is probably going to be super easy. And okay. Admin's false and the method is get. So I'm just going to copy this and I'm going to change this to true. I'm not sure if you can see it. Let me maybe make it a little bigger. Yeah, so I'm changing this to true. And competition is actually, picoCTF. So, okay, and now I need to do it again. And this is the flag. So that's just it. I just changed the URL to this part in the address bar of my browser, and that's it. That's everything that had to be done. So I guess if you're super new, you might be wondering why did I focus on this? So I focus on looking for where the form is submitted, and the form is submitted here. There's an HTML tag called form, and the action points to the server address basically, which the form is to be submitted to, and it seems to have some parameters here. That's quite weird. You normally don't put parameters there. So yeah, and a parameter called admin equals false that rings a bell basically that you should probably change it to true because you want to be perceived as an admin. And competition, I just guessed it's picoCTF or picoCTF. It might be something else. But well, it made sense for this. So yeah, so that's solved as well. Now try them all. You have found a password, a passwd file containing salted passwords. An unprotected configuration file has revealed the salt of 6191. The hashed password for the admin user appears to be this thing. Try to brute force the password. I can try to brute force it, but I don't know if this is hexadecimal or not hexadecimal, and how the hash is actually calculated, because the salt could be at the beginning, could be at the end, it could be like a normal Linux file, but I don't know. This looks like MD5 actually, an MD5 hash. No, I'm not going to search for it because picoCTF is probably already well described and that would spoil the challenge, so let's not go there. Instead, I'm going to actually write a short brute forcer because why not? It's going to be probably really easy, or not. Okay, I'm going to write it in Python. So the hash, h is this thing, the salt is this thing. I don't know if it's hexadecimal or not, so I'm going to actually use two salts. And I'm going to assume this is hexadecimal. I'm going to decode it. Actually, so 61 and 91, that's, I absolutely have no idea. But no, it might be both. It's not ASCII, but it might still be both. And how to brute force it? So I said it's MD5, and I say that because it's, the length of it is actually like 32, and that's the normal length for MD5. And since this is an entry-level CTF, we're not going to go for some weird encryption. Okay, I'm going to import MD5, and just that. Let's assume that for now, that the hash is actually created like this, that you take the salt, you take the password, you hash it, and that's what comes out. That's usually the way you salt. You might add the salt at the end, you might add the salt on both sides of the password, but I don't know at this point. What do we do? The password might be like an English dictionary, or it might be like one word. I have no idea. I actually do have. Yeah. So I actually do have a directory called like CTF crypto where I have some dictionaries, and there is a dictionary called EN, which is I believe English words. So I'm going to probably use it. It looks like this. Yeah. Just a lot of English words. I'm going to use this one. So I need to open it. And again, I'm on Windows, so CTF, crypto, and EN. And it's opened for reading now. So for line in F, that just like reads a line from the file basically. But I need to strip it because there might be like the, the char which ends the line at the end, like line feed or encourage return or both. So I need to strip it. That's okay. And now I can like attempt two passwords. Therefore, like password 1 will be, let's assume it's salt plus, well, my line, which is the thing which I'm going to test, and md5.md5 is actually the function which I want to call, which calculates the hash. And the hash is, but, I'm actually going to do it in a different way. Yeah, I'm going to like write all the different combinations that come to my mind here. There aren't a lot of these, and it should be quite fast anyway. Like both or at the end. I'm pretty sure it's actually at the beginning, but yeah, just to demonstrate how would I approach it if it wouldn't be an entry level CTF. So it's going to try like all these and so password is blah 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 of p and hash digest, it's like hex digest. Hex digest returns this basically, which is the hash itself in a text format, which is hexadecimal encoded. I do hope this is lowercase, but I'm going to print it just to check if everything works. So yeah, so just let's run it. Into open a console here. Yeah, it's lowercase, so that's good. So now I can just compare. So if p is now it's equals to the hash, which is h, then print not p, ln, which is the password. And then let's see. Yeah, entrapped. It's like that was super fast. Like one of the first probably passwords. So yeah, so entrapped is the password. I'm actually quite curious, like which option of these works. So I'm going to do like something like this. Because I changed the name, let's change it to pp. I'm going to write, yeah. So the salt was at the end. So I was mistaken when I said the salt is at the beginning. So good that I actually checked it. In which CTF team do I typically play? In Dragon Sector. I'm the captain of Dragon Sector, technically. Though acting captain is actually Valis right now. Since, the book and stuff, I didn't have too much time to play. No, without the salt, just entrapped. Okay, that's correct, solved. I'm going to put this on GitHub probably later on, if you're curious, but the code is really easy. Can close all the windows now. Actually, after each challenge on a real CTF, I close windows, and it takes like 10 minutes because I have 50 windows everywhere. I'm actually using a 4 display for LCD configuration, so quite a lot of space to have a mess. The map of the spaceport is hard to parse, but you're pretty sure there is some hidden information somewhere. And it's a... What is it? Is it a GIF? I'm going to save it. Yeah. And I'm going to copy it to my CTF directory. It is a GIF. So let's open it in Irfan view. Okay, so the usual, it looks like steganography, basically. There seems to be like a, yeah, like a one frame which skips really fast. I'm going to do two things. First of all, I'm going to open it in GIMP, because GIMP doesn't support animated GIFs, but it does open each frame on a different layer, therefore I can analyze it like without, you know, it skipping too fast. And there is a frame, actually, I don't know if you see it here, I'm going to zoom it, but takes only 10 milliseconds to display, and that's fishy. So let's see what's the frame. Okay, what does change on this frame? Oh, sorry. I need to display this frame, I need to click like show only this layer. I always forget the shortcut for this. Oh, key. Do passports let you fly in interstellar? Is that the flag? Should I just test it? Yes, I'm going to test it. It's a good question, actually, I don't know. Yes, jawohl, correct, perfect. So yeah, again, in this case, I just had to open it at GIMP and see like how many, and look for the frame which looks fishy, which is displayed only like a fraction of a second. Or 1 millisecond, 10 milliseconds actually. Cool, so that's it. Let's continue. Can you put the dictionary too on GitHub? I'm not sure. I mean, so it's actually a dictionary I found on the internet, typing English dictionary cracking in Google. So you can find it there. I don't own the copyrights to the dictionary, therefore I should not put it on my GitHub, basically. KrzaQ says the spelling isn't correct. The jawohl is spelled differently. That is true, I believe. I live in a German-speaking country, but my German is sehr schlecht. Schlecht. I don't even know how to say it. But okay. Bitwise. You see the doors to the loading bay of the hangar, but they are locked. How unfortunate. However, you are able to extract the password verification program from the control panel. We are very resilient. Can you find the password to gain access to the loading bay? And we can do the problem either in Python or Java. I'm going to do it in Python because I know Python better. Okay. The program is really short, as you can see. Okay. So it looks pretty easy. The password has to be 10 digits, 10 characters long. And then it compares if whatever we typed in, or this is a rotation. This is basically a bit rotation. It's rotated like rot 5, basically. But it's a bit rotation. It's a bitwise rotation. It's not a, you know, like rot 13 or the Caesar's cipher. It's just like a bit rotation, like assembly level. Then it's XORed with 111, and then it's cut to byte level. And it's supposed to be equal to this. So we can do it two ways, actually. First off, we can reverse this operation, or second of all, due to the way the comparison is made, we could brute force it, character by character. I'm going to actually show you two ways to do it, because, I mean, it might be useful for you in the future. So first, let's reverse it. So there are actually like a couple of operations. We can totally ignore for now this one, which is, we'll probably add it in the end, but this is just to be sure that the result is actually fits into 1 byte. Then we have XOR is basically the operation which is done last. So this is the first thing we need to do. So I'm going to cut it out and I'm going to do like this. Yeah, but not user submitted. Verify we are actually, you know, reverse engineering it and reversing it. So we do like this. X equals ort char. Ort actually, you know, returns the ASCII number or Unicode number in case it's Python 3 of the character. Then we XOR it, and then we need to rotate it. So the order of operations is like reverse, right? First, here is like first rotation, then XOR, and we do the other way around. And we can actually copy this XOR and just change the numbers. Or we can stick with these numbers. We can do this, like change left to right and right to left. This is fine, and then we can do this, the last operation. And now we are going to add it to user array. That's actually good. Let's append it to user array as well. And at the end, we absolutely don't care about this, but we want to print it, and this is the way you print an array of characters. But this is not a character, this is a character. Yeah. This is the way you print array of characters in Python. So you basically join with an empty string. It puts an empty string between each characters and forms the string out of it. Now I can run it, enter password or whatever. Wait, I need to comment this out as well, my bad. Yeah. No, this is already an ordinal, so yeah, because I'm using this array, these are like already numbers, so I don't need to use an ordinal. I just need to do this. And it almost worked. Let's see what I screwed up. So they take this and they rotate it, and then they XOR with this, and then they do this. This should be actually fine. Why is it working? I'm going to re-download the original one, or do I have it somewhere? No, I have it somewhere. Just to see if like I didn't change anything by accident. Let's maybe split this. Maybe I should. No. So this looks fine. Am I rotating it correctly the other direction? I'm rotating it 5 places, and then I'm pushing the 3 places. No, this isn't correct, I think. Or is it? No, it is correct. It looks fine. Yeah. Should this be the other way around? I don't think so, but yeah, let's try it. Why not? No, it's not true. So chart to X, thank you. Yeah. My bad. Oh, that's stupid. Yeah, Uber secret, thank you. Shout out goes to who spotted it first. Store. I think Store spotted it first, so thank you. Well done. Yeah, I was like not using the variable which I was overwriting. So this is the one way you do it. I'm just going to submit the flag, and now for the other way you do it, I'm going to close this, and I'll show you how to brute force it. Oh, maybe here. This is the original version. I just like changed this, right? So the idea is here that they are comparing both arrays, but the comparison is actually done, you know, byte by byte, and also the operation is like done byte by byte, which means this byte isn't affected by changing any other bytes. And this is the best case scenario for brute forcing, because you can basically just check by byte by byte if everything is okay. Therefore, what I'm going to do is I'm going to keep this, and I'm going to change it a little, and let's call it X again. This isn't important. This isn't important either, too much. Now, for every character in, no, not in very far, well, actually in range, I'm going to do something like this. Range and how many characters are there? 10, right? Oh, I can do this, verify array. So for each of the 10 characters, I would like it to pick a character from a printable range. Usually brute force, when you brute force, you try to minimize the character set, and you are not going to brute force the whole extended ASCII or the whole Unicode, because that's not really, you know, that's too much. You cannot enter some of the unprintable characters anyway. Therefore, the range for me will be starting from, 32. 32 is like the first printable character in ASCII. It's good to know the ASCII table. Just in case there are any beginners here, I'm going to show you the ASCII table. You don't have to know, like, remember it, but it's good to know how it's constructed. And actually, yeah, the first printable character is here. This is the first printable character, which is 32. This is why I said 32. And the last printable character, it's actually here. It's this one, 126. This is a tilde. Yeah, the next one, 127, is not printable anymore. So in case of initial 7-bit ASCII, which we are usually interested in, we just range from 32 to 126 plus 1, because range decreases 1. But we want to also test it. And we're going to check it. You know, I can actually change this as well, because I need something to compare against, so let's just do this. And if x is equal to p, then I print the char. Yeah, and this is brute forcing. I check every character for every position, and if anything fits, then that's good. And that's the old program, so... And this actually expects... It's already a number for me, so I don't need to use ORD, because I'm using range, and range returns the number. Yeah. Uber secret. We might not want to print it in a line, so we can do it like this, like import sys. And we want to write it to standard output. Yeah. And again, it's the same flag, and it's the second way to do it. So Laksa also says that you can do import string and then use something like this. I'm going to copy paste it. Yeah, there's something like printable, string.printable in Python, which is true, which is worth to know. I would argue that this is less typing than typing this and this, but I mean, both are valid solutions, and whatever works in CTFs. So yeah, both. It's actually thanks for pointing that out. Cool. This one is done. Then yummy. As you can see, we are like increasing the time we spend on each challenge, because the points are growing for each challenge. You want to find out the docking bay numbers for the spaceship that are already launched. Luckily for you, the website for the docking bay ship status page doesn't seem to be so secure. Enter the docking bay for any of the ships which are awaiting launch. You are not authorized to view this page. Again, we start with looking at the source code. Okay, this is expected cookie. This is the bug. Obviously, on any real website that would never appear, which isn't true, because when you start pen testing, you find all sorts of weird stuff, and this isn't the weirdest I ever found. But yeah, this is an easy task, so they basically give us everything. And there is some authorization administration. This is the cookie which it expected, but it didn't. But it received other cookies. So, well, we need to, you know, set this cookie basically, and that's everything. So I'm going to launch this, which is a JavaScript console. It's I just pressed F12 on my keyboard. If you don't have F12, I think you can press like Control J or something, Control H. Yeah, I don't remember. How do you set a cookie in JavaScript? I always forget. Is there like a document cookie? Can I just set cookie? Can I just set it like this? Let's see if it complains actually. Blah blah blah. I think there was a function actually to set cookie. I always forget it. I always need to look it up. Blah blah blah. No, I'm supposed to be able to set the cookie. Why is it complaining? Why? But why? No, this is weird. Oh, right, because I'm viewing the source, so I cannot be doing it here. I should be doing it here, so that's my bad. No, okay, let's do it again. Yeah, the cookie is now set. I'm going to refresh the page and ta-da, done. And I can, you know, like just use this document.cookie to display all the cookies, and you can see that my cookie is also set right now. This is the easiest way to do it. You could also use some other tools, like Firefox, for example, has this great add-on which is called like Fire Cookie or Fire. There was Firebug, and at some point you had to install a module to handle cookies, but I don't know if they integrated it at some point. Anyway, okay, based on the chat, I see that some of you are like skipped a little, like at the beginning of the stream. Anyway, awaiting launch. So any of the ones which are awaiting launch, for example, this one, and it's solved. So that's done. Then bytecode 70, you need to authenticate with the guard to gain access to the loading bay. Enter the root password from the Vault application. This class file. Class file is a Java file. It's a compressed Java file, which is great. So it downloaded. It's actually a zip file which downloaded, but I unpacked it. And it's called authenticator.class. So there are a couple of ways to go around it. This is probably going to be a crack me, but just in case it isn't a crack me, I'm going to run strings on it. Strings just like tries to find anything that looks like a printable set of characters, like one after another, in a binary file. And I'm going to run strings on this. And this is the magical string. This string looks fishy, and I'm going to copy paste it here. Nope. But I'm going to remove actually the last part. Nope. It was worth a try to do it, but it seems we need to do it correctly. And to do it correctly, we need something called JAD. I'm pretty sure I have JAD installed. Come on. JAD is a Java decompiler. That's usually what you want to do if you get a class file. You want to decompile it to a Java file. A .jad file is basically a Java file. So I did it. I think JAD is like, I'm not sure it's actually maintained anymore, but if you look for Java decompiler, I'm pretty sure there was a website which you could do it on anyway. Oh, so there's something called JD now. Yeah, you can download it. And you can, yeah, so. And there's an online decompiler as well, so we could upload it here. But I'm not going to use it since I already, decompiled it on using JAD. And what's going on here? We need to analyze the code now. So it creates a key out of these characters. That's why string didn't find it, because it's like split into several instructions actually. And then system console, if for string, oh, it reads the line. And then, okay, so if I run this application, it actually should like display me this key. Okay, so I can either run the application. To run the application, I just need to type Java and I have Java runtime environment installed. Now the name of the file, but without the extension. Now it wants the password, so I'm going to copy paste this, and it gives me this. So I just could type it from here, but just to show you that it actually works. Nope. Oh come on, I'm pretty sure. Oh, because there's a P which I didn't copy. Yes, there's a P which I didn't copy. My bad. Alright, that's correct. So another task solved. Now, CFG to C. Wouldn't it be cool to be able to have one of these patrol drones to do your bidding? Figure out the correct sequence of C functions from the following control flow graph, and you should be well on your way. Submit the correct order of functions. Okay, this doesn't ring a bell. Match the control flow graph on the left with the correct C function on the right. Submit the correct answer, like, oh, okay, so I get it. I need to check which, like, each function which doesn't match one of these functions. And this is actually a really cool reverse engineering task for beginners. I mean, that's pretty awesome, and I really love this task. So let's do it quickly. This is Intel x86, but AT&T syntax, which means that I need to remember that the arguments are reversed. I usually use the Intel syntax, which has first the destination and then first the destination and then the source, but this is the opposite. So let's look here. Okay, so this is an easy function. It just does division. Basically, what's it called? Reminder of a division or something like that. Modulo, basically. Then we have a loop here. If there is a loop, then you usually have an arrow which goes like this, like upwards. So there will be an upward pointing arrow here because you have to. If it's a loop, you have to go to the beginning of the code, right? At this point, you have to go to the beginning of the code. So there's usually like in the control flow graph an arrow pointing upwards. Then this is an if, so this will be like easy. It's just going to look like this. There will be a block which does some check, and then there will be like 2 blocks there. And each block actually returns, so it's either like they return or there's like a common block afterwards, which they go into, and this one returns. And the last one is also a loop, so there are 2 loops basically, one if. So yeah, let's try this one for starters because it's the easiest one, and I'm going to open some notepad so I can note the order of the functions. Or we actually should go like linear way. So this is one loop. So first one is either like even without reading the code, first one will be either B or D. So that's going to be the first one. Then the second one, I'm going to dig into it later, or just brute force it because why not? This one is the if case. As I said, like 2 arrows going down into 2 separate blocks, and then they go into one common block and return. So this is going to be the if case, which is C. So I know that the second one is C. The third one is again some, loop, as you can see, like there's an arrow going this way. So that's another loop. So that's again D or B, I don't know. Therefore, the last one is just the division, as I mentioned, right? Like this is just the division. Yeah, so KrzaQ says it will be like easier to brute force everything anyway, which is true. Yeah, but I'm going to like not even analyze the rest. It's either B, C, D, A, or it's D, C, B, A. It's one of this one. No. Yeah. Yeah, correct. Okay, so even without reading the assembly code, just looking at the control flow graph. Sorry, my English is terrible. So that is solved. Therefore, we have another task, and the points are growing again. You've gotten a partial dump of the disk from the Hangar's machine. This is something I can download. And you're pretty sure the password is cleverly hidden somewhere within it. The disk image can be found on the shell, and the contents of the image is available here, but I could download it, which is great. And it's 24 megabytes, so it's still downloading for me. And it did download right now, therefore I could copy it. And this is the file. Yeah, like a binary file, right? So what do we do with this? We can, we're not going to look in a hex editor because that doesn't work. Probably let's run strings on it, because why not? Running strings is always a good idea. You don't get to solve challenges using strings too often, but it happens. Strings. And I'm actually going to do -n10 this is like how many letters have to be printable. I'm sorry. I'm going to dump it into a file. Let's go txt, and I'm going to look through a file right now. Yeah, gibberish, not interesting. Then there's some swap files. This looks like part of an either a PDF or an image. This definitely looks like an exif from an image. So yeah, it's probably an image. We need to over like cats and some text files. Huh, that's funny. Oh, the pilots. Is it? Is this really a flag? Yes, it is the flag. So actually, using strings, we just solved the challenge. How to do it correctly. I'm going to show you how to do it correctly, actually, because that's, you know, it's supposed to be an educational stream as well. So what I usually do is I enter my blog, and there is like /n thing here for notes, and there is something called commands I usually forget, which are the commands I usually forget. Yeah, commands I forget. And it's written here how to mount a disk image on Linux. So I'm going to spawn a Linux console here. Yeah, that's a Linux console. Going to create some mount directory. I'm going to call it M, and I'm going to see with fdisk how many partitions are on this disk image. So that's -p if I remember correctly. It's an has-been. I need to fix my path. No, L-L. Sorry, list obviously. It's doesn't contain the valid. So that means that's probably a partition image. Yeah, that's x2. That's a partition image. Therefore, I can just mount it. And to mount it, I just run this, but without the offset. The offset is only required if it actually would be a disk image and not a partition image. Therefore, I can do sudo mount -o loop and then the name of the file, which is pilot image, and then the directory. Now I'm going to turn off my microphone because I'm going to type my password. And yes, there is some research which says that if you have a good recording of somebody typing a password, you can actually learn what password is it. So, home and lost and found. Let's do a find dot, which displays all the files here. And well, there's some desktop, some pictures of cats. Pictures of cats are really important. Then documents. Then there's guardbot. So what were we looking for? Sorry, this is not it. This is it. We were looking for the guardbot, right? Pilot's password. Oh, so it's not the guardbot. So pilotbot maybe. Maybe it's somewhere here. Oh, look, this is what we want basically, right? So I'm going to just cut it. Yeah, and that's it. You can take this guys from me is the same thing we found in the strings, right? Is it? I'm sorry, I actually had it open in Vim, I believe. But I did close it already. Yeah, where was it? Just after the long blank space range. Oh, sorry. Okay, now you should be able to see it. Thanks, KrzaQ. And it was somewhere here, right? You can take, yeah, that's it, basically. That's funny, like, forensics problems, well, what's this? But okay, yeah. So that was the proper way to do it, actually. And let me unmount the directory now. Wait, where am I actually? Okay. Okay, now it's no longer mounted. So, that's how you... Przemek says that there's also research which says that you can get the password from by watching somebody's eye movements. Probably not on this resolution though. I'm pretty small here, but maybe. But that's cool stuff actually, a cool idea. And some more challenges unlocked for me. So, okay, I'm actually streaming 1 hour, so let's do it like this. Let's do a 7-minute break, and after the 7 minutes I'm going to be back. I'm just going to let my voice rest a little. If you have any questions, then just like ping this guy, like my moderator today, KrzaQ, and he will pass the question to me. Yeah, So yeah, see you in 7 minutes. I'm going to leave you with some music. I'm going to mute my microphone though. And we're back. No, I'm already here. Perfect. So, let's see, we solved already some challenges, and there are at least 4 visible to go, because as you can see, they just appear after you solve some, which is quite cool actually. So, RSA is the next one. RSA is an encryption algorithm, a public key encryption algorithm. Use the RSA algorithm to decode the secret message. Okay. And here are... Okay. So yeah, so basically everything is given to, so we can calculate... so these are like, RSA works like this. There are 2 primes, like P and Q, and you calculate both private and the public key based on it. Then you have C, and then you have E, which is exponential, and C I have absolutely no... Oh, is an encrypted message, I guess, in this case. So we're going to use Python because that's usually the easiest, because Python has actually multi-precision arithmetics, which I don't believe any other language by default has. Which means this is also like valid Python code actually, so I'm going to just copy-paste it. Yes, I know. Okay, cool. So, and now I don't remember. We need to open like wiki RSA. No, but in English, please. And blah blah blah. And decryption. So decryption is Alice can recover M is the message here by using C, and they raise it to the power of D, but it's done modulo M. So which means message. So we need to get D. What's D? How do you calculate D? Blah blah blah. Come on, how do you calculate D? It's a modular multiplicative inverse of E and T is this. So let's calculate T. I'm going to create code by copy-pasting. Probably not the best way to do it, but why not? And then D is multiplicative. How is it implemented? And sorry, one more thing. So that's E. E we have given, right? Yeah, that's a default E. It's like 1001 in hex, if I remember correctly. Yeah, 1001 as said. Oh, Rabbi. KrzaQ says that Rabbi has big ints, big numbers as well, as default. Okay. And they use this complicated thing, which I don't like. I'm pretty sure it's easier to... it's way easier to do it in Python. Yeah, so this is the part where I'm reading the documentation. D mod P, okay, but how do you calculate D, please? Okay. Okay. So, I'm going to do something like this. Copy this and type Python at the end. This isn't an algorithmic or coding tutorial in the end. It's like how to solve CTF challenges, and you don't solve algorithmic challenges by wasting time. Okay. So let's see if it works. And then I said to raise, what did they raise? They raised E to the power of T, ET. Does it work? It does, so this is my D, right? Yeah. And now to decrypt, since I have everything to decrypt, I need to raise the message, the encrypted message, to the power of D. So that's going to be power... I'm pretty sure like Python has modular power, so it's going to be... I pressed space, I think. Yeah, okay. So it's going to be my C, which is this is the encrypted message, and I need to raise it to the power of D, and this is going to happen modulo N, which, do we have N defined here? What is N? N was something easy. Yeah, P and Q. N is just, sorry, I need to do this. P times Q. You can see the bottom of the console, you can. Okay. So again, cipher to the power of this module of this. And this is what we get. So, like, my message. This is my message. And I probably need to decode it because, you know, this is just a number, but I need to bring it to a text value. So the easiest way to do it is you change it to a hexadecimal number, because in hexadecimal number, every two hexadecimal digits, which are called nibbles, form 1 byte. So it's really easy to split the number into bytes. So let's do it. But no, probably they don't want us to do it. They probably want this as a result. And I'm saying probably no, because these are not printable. Like, this is not a printable ASCII character. This 05 isn't a printable ASCII character, and so on. So yeah, so I probably want this as an answer. It does look like human formed anyway, right? Is this the answer? It is the answer. So yeah, so that's it. But usually if this would be like real RSA, you would have to actually do this, and then you would have to take like actually this part of it and do .decode hex, because this is hexadecimal, and this you would get normal plain text here with some padding probably at the beginning, or well, at the end actually, and it might be like reversed as well, so you might have to do yeah, this is like reverse string in Python if you didn't know. So yeah, RSA solved, and this was solved by googling on Wikipedia and like for an algorithm on Stack Overflow. And seriously, if you're playing like CTFs, you Google a lot, you look a lot. You don't have to remember everything, every algorithm, how to implement it, and you reuse codes of other people. Not a lot. I'm not going to say a lot, because a lot of the code is either faulty or needs to be re-implemented or like adjusted to the challenge, but you do look at it. Client side is best side. Luckily, the ship has a web-based authentication system. Even though you don't know the password, I bet you can still get in. So is this another... Yeah, we do again what we did every time, which means we view the source code, right? And the source code is... Well, you can see already this function, right? There's some MD5 implementation. It says that it's standard MD5 implementation, which is good because it might be non-standard. If you get like a Web 400 challenge and suddenly you check if this is really the standard MD5 implementation, if they didn't mix the constants, or if they didn't mix the order of operation, the number of rounds, or so on. But no, we believe this is like 75 point worth challenge. It's not even 100. There isn't going to be anything fishy here. Cool. So they check if the password is this, and then they say it's correct, and then they move the document here, but we are not going to enter the password. We're just going to copy paste this, and we're going to yeah, do this, and that's it. Yeah, because the logic here is if the password is correct, which you entered, then it's checked by MD5, and this is probably some uncrackable, really hard MD5, because that's usually how you choose in such challenges. If you enter correctly, then it moves the browser to this location. And this location is obviously, you know, the one with the flag, which is this. Therefore, yeah, it's solved. And we have some new challenges opened. Whoa, quite a lot of them, actually. So I'm not going to finish today. I think it is like all the other challenges are available on the CTF right now. Let's go from the top though. Trivial. An unlocked terminal is displaying the following. Encryption complete. Top secret key, blah blah blah, blah blah blah. You poke around and find this interesting file. Okay, so this is like a pretty standard crypto challenge, which is you have, well, okay, it's not standard because they give you the key. So we have the key, we have the encrypted message, and we do have a file which generated the encrypted message, which means it's more of a reverse engineering challenge where you have to you take this is the code I just downloaded, and you reverse engineer it and like reverse the operation. So let's see what's happening here. So the key can be only alphanumeric characters. Then it does some rotations, and okay, and then when it's complete, it says the plain text is this. the key is this, and this is the cipher text. So, well, we get most of it, we just don't know what's here, and this is what we are looking for, right? Oh, okay. So KrzaQ says that the MD5 is not uncrackable at all. Let's use his link and see. Oh, it's dinosaur. Okay. Yeah, I guess that's like another way to do it. Perfect. So, what do you really do here? This is lowercase, uppercase. So for len plain text, you what's keychars? Oh, keychars is this, right? It's like top secret key. So that's it. And you based on the what's oh. So they select and keychars. What does this do? Because this actually looks in the index of keychars. What does it look for? Oh, of key. So it looks for the first letter. What's key? What's key and what's keychar actually? No, keychars are this. Is like this. Okay, never mind. So it's like, let's call it alphabet actually. That will be easier. Let's go to alphabet. So keychars is alphabet. So in the alphabet, it looks for where on what index is the next character of the key modulo length of the key placed, and that's the rotation amount. And then it does the rotation. So basically this is like a, like, you know, we did the Caesar cipher, like the rot cipher at the beginning, and this is the same, but for every letter actually it's a different rotation. So this should be like super easy actually. Also like this. So what do we have? We have this, right? So this is the plain text. Yeah. So the plain text to us is this. The key, we also have the key. I'm just going to hard code it here because it speeds up things. I'm going to also get rid of this. And now I need to reverse it. If it's rotation, then reversing it should be like super easy. And by super easy, I mean, where is this bracket ending? Okay. So it takes the number and it does the rotation, and I need to change the rotation amount by, I need to basically do a reversing of this. So it's 26 minus, and this should be like decrypting instead of encrypting actually, and in the end it will tell me the plain text. Let's see if it's enough, if it's like adding these 3 lines of code is actually enough to decrypt it. I'm sorry, what is it called again? Encrypt. Invalid syntax, why is it? Oh, because I forgot the advanced sign. Yeah. So blah blah blah. You have success. So not everything works for me. You have successfully decrypted the message. Decrypted. Okay. The key is. I hope this works, or I will have to decode, like check where I have a bug. Yeah. That's worse than. Yes, I do understand my problem. So my problem is actually that it's 26 for these 2 cases, but in the last case it's actually 10. Because, you know, it's 10 here, it's modulo 10, right? So now let's do it again. Yeah, that's worse then. Yeah, that's better. Okay, now it's correct. Yeah. So again, to fix it, we just had to know that the rotation cipher, like, it's super easy. You just change the number, the key used to the reverse of it, and the reverse is like actually subtracting the key originally used to encrypt from the number of the alphabet size in this case, and it's 26 for these cases and 10 for these cases, and that's it. So yeah, that's it. Next. And again, if you have any questions, then pass them to KrzaQ, and I do actually see there are some questions. So let me look at the chat right now. Actually, to what KrzaQ pasted me. Okay, so there's a request to do a live stream on reversing some harder challenge, like a binary challenge. Yeah, sure, we can do it at some point. But they can, so it's like it cannot be too hard. For example, like on my Polish streams, I did solve from a picoCTF a challenge, a reverse engineering challenge for 200, and it took me 6 hours, and that was like 2 hours on stream. Then I took it off the stream, finished it, and showed basically in the 1 hour on the next stream how to finish it. So it cannot be like super hard, because for super hard it takes quite a lot of time. But yeah, but something harder than this, because this is really easy. This is entry level CTF, but it's how it's supposed to be. Cool. Yeah, GameMind says that he would prefer me to stare at the screen instead of him staring at the screen. That's one way to approach it. Okay, cool. So, thank you for the good feedback as well. Let's continue the challenges then. If you have any questions, then yeah, message this guy on YouTube or on IRC, and he will pass it to me. We actually, I have these headphones, and we are connected on a voice chat, so if you guys say anything, he does tell me. Okay, there's a request to not go in order this time, so to skip this free. I'm a little afraid about these challenges, because again, they might take quite a lot of time. But there is something which says ROP. I love ROP. Let's do a ROP of this one. It's 95, so it's getting harder. Let's do it. If someone's Python eval, I like Python as well, so let's do it later on. It's downloadable here. Let's see if it actually works for me. So ROP, what's ROP? ROP is return-oriented programming, which also was called return to libc at some point. It's basically the idea that when you do a binary exploitation, and the standard buffer overflow on a stack, and the stack is not exploitable, then you can reuse parts of the code which are already in memory to do your bidding, actually. So yeah. So that's the idea. You don't execute your code, you execute code which is already in memory. That's how return-oriented programming works. And it's called return-oriented programming because each snippet of the code which you reuse actually has a return instruction at the end. So on the stack, you put the return addresses to the snippets in memory, and they just jump between each other due to the return addresses on the stack. That's in short. You can actually look for tutorials on the internet. I'm pretty sure on my blog there's like return-oriented exploiting. There's a tutorial on that as well. Yeah. That's actually in English, but I'm pretty sure in Polish. I'm pretty sure I have one in English. Yeah, I have one. So feel free to just look through it. It's from the time when I was learning return-oriented programming, and it was 7 years ago. Well, time flies. Anyway, and basically, I like to learn stuff by redoing it. So that was the post is like basically my notes on how to do it. But okay, so did I download it? Yes, I did. I'm going to create a new directory then. Do I have any windows open? No, just this. Perfect. So this is the. This is going to be really easy. I can already see because they have system bin bash there. If you have a opcode like that, like a gadget like that, was like problem solved. And there's a vulnerable function, so let's just read through it quickly, shall we? Be nice to people, then vulnerable function, and then it says hello world. And be nice to people is okay, so it just like resets the so the problem is here, but again, I cannot get into the shell, right? And this is a problem which is solvable on the shell machine. Therefore, I can show you how to exploit it, how to solve it, but I cannot actually get the flag for this challenge. Yeah, that's life. It's not a real CTF anyway, so as in it ended 3 years ago, so no worries about that. And it reads 256 bytes into this buffer. This buffer is obviously a local variable, which means it's on the stack. Therefore, after the variable, there will be some return addresses which I can overwrite, and is read, which means we do not have to care about null bytes or end of lines present in our payload, which is good. Cool. So let's do it. Let's see if that actually runs on my machine, the challenge, because apart from this source file, I also downloaded the binary. This is the binary, so I can do this. I can also do, there's a cool tool called CrzaQ.sh. CrzaQ. Yeah, CrzaQ.sh, which tells you what kind of protections are there in the binary. And this one has NX enabled, which means I cannot execute code on the stack. NX stands for like no executable. It's a no executable bit in the virtual memory, because before CPUs actually had this flag, you couldn't mark a page as non-executable in memory. Well, you could mark it on the operating system level, but the CPU would not enforce it in any way. But that was like Windows XP Service Pack 2 already had this implemented. They called it DEP, Data Execution Prevent. And it was supported on the CPU back then, and that was like ages ago, like 10 years ago, 13 years ago even. So yeah, so it's was it no stack canary, that's good. No ASLR, which is also good. We don't care about the rest of the stuff. So yeah, it should work actually. I hope it works. Does it work? It's statically compiled, right? Is it? No, it's dynamically compiled, but it seems to work anyway. Yeah, it works. Okay, so let's just crash it for starters, right? And how to crash it? Well, to crash it, I have to enter more than 128 letters. So I'm going to press Alt and I'm not in a bash, so let's do it like this. Echo and now Alt 150. Okay, perfect. So that was Alt and digits on bash, but they do that. And yeah, and it's a segmentation fault, which is good, which is exactly what I expected. We can run it under a debugger. I'm using standard GDB without any scripts, but there are quite a lot of good scripts there. Yeah, and it crashes on this address. And this address is, 41 is actually the ASCII code of the letter A, which means my letter A overridden with it, which is what I expected, which is perfect. So let me exit it, and now I need to somehow create the payload, but before that I need to also find where is this not called function stored in the image, and to do that I'm going to, well, I would normally run IDA, but we can do it in another way. There's something called object dump -d is to disassemble, and this is a standard Linux tool, so I'm going to use it. The disassembled stuff, and I'm now going to look for that function. What's the address of that function? And the address of that function is... yeah, it's here. So this is the address of this function. Right? Now, I need to... I copied it into my memory, and now I need to create an exploit, which is actually like more a shellcode generator than an actual exploit. So this is the address, and what I need to do is I need to, actually this is going to be super easy. Let me encode this address in, let's do this. And basically what I'm doing is this is a poor man's way to encode this in little endian. I probably should have written like this. 840408. So yeah, basically, in memory, the bytes of variables which are larger than 8 bits, of numbers which are larger than 8 bits, are called in reverse order, in reverse byte order, which is called little endian. Therefore, I needed to write the same number, but bytes reversed, which means the first byte actually goes at the end, and so on, and the last one goes at the beginning. So this does the same, but yeah, let's keep it like this. And I need to print it at least like 128 plus something times. So A times, but 128 is in bytes, and I know these are 4 bytes. Like I can count 1 byte, 2nd byte, 3rd byte, and 4th byte. So 4 bytes. But let's increase the number even a little, because this will not overflow the buffer. I needed to overflow the buffer, so I'm going to go this. And yeah, that's basically it. Python, what did it exploit? Yeah, and this is the result, and I need to pass it to the application. And it's segmentation false. That's not great. Therefore, I'm going to actually write it into a file. I'm going to see if everything is correct, so I'm going to cut the file and I'm going to put it in hexdump, which displays. Is everything okay? Is there no funky stuff going on with encoding? So this looks fine, unless I screwed up the address copying, but looks more or less fine. Let's see what happens when in GDB, shall we? Okay, and the file which I created, I'm going to copy it to standard input of the device, and it crashed on this. Why did it crash on this? That's the... No, seriously. I'm going to strace it, maybe. strace is a really useful tool. It tells you what's actually, like, what syscalls are being called by the application. And again, I'm going to pass this. Right. So it tries to spawn a shell, actually, it seems, but that doesn't work for some reason. Why doesn't it spawn a shell for me? It means this doesn't work, basically. Yeah, I can do like -F and see why it doesn't work. Maybe it works. Maybe I can just exit this shell and I will be... Maybe it actually did work. No, it didn't. So let's do it like this. Let's see the log. Okay, blah blah blah. Here it reads my data, right? Now, and this is where it starts to do... it starts to run system. Because it read the data here, it exited, and it should start calling system at this point, which it seems it does. It does execute execve dash this, and it does load the code. Why doesn't it span a shell for me then? It executes bash. No, and it runs bash. It does run bash. Okay, does this process actually end? And it exits. But it does run bash, so I can actually assume it does work. Oh, I know. Because what I'm failing is I'm... let's do it like this. Let's do this, and... The problem is that after reading like the 256 bytes, I close the output, which is bad. I shouldn't close the output, so I need to do this. I need to actually do this, and after it, I need to pass the commands to bash. So yeah, so I do this, and now I pass the commands to bash, which are supposed to run. What are we going to do? We're going to write out the date, okay? So date. Yeah. Yeah, it works. It executes our command, so that's fine. So everything is okay. I just closed the standard input stream, therefore bash, or well, if you close like the input stream, I have nothing to do, and it exited. So everything's fine. So that was super easy in the end. More reading than actually writing the exploit. The exploit, as you can see, is super simple. You just return to function which spans bash, and then we give it a command. And after this command is obviously it closes the shell as well. Oh, so actually GameMind, I can see now on the chat, showed me something interesting. He says to do something like this: cat AAA, and dash is for standard input, and to redirect this to does this actually work? Ha! I didn't know you could do that, so thank you. I actually learned something. Game mind like props. Thank you very much. That's really cool. But again, I cannot exploit it on the shell because I have no access to shell, but yeah, this is solved. I'm going to say it's solved. It's recommended that you do Python eval1. Where's Python eval1? Let's do it then. A wise master wishes to teach you ancient art of eval. Eval, and you actually shouldn't call it eval, you should call it evil. Evil is the function which executes code which you pass to it. Now, you... okay, task 1, perfect. So I need to pass a number, and I need to pass a second number, and then it outputs something. And I can get to it by running this command. Okay, so I need my console actually. Let's see if it works. Yeah, it works. Enter first number 1. Enter second number 2. Perfect. Now, what do I have to do? Blah blah blah. Your job is to get it to print out the secret flag. Okay, so input is actually, I think they are telling it here, but input I think executes Python's code. We can try it, like read about it in the documentation. It's actually really good to read about the functions which you don't know during a CTF in the documentation, because there are like sometimes there's quirks there hidden. The function reads from input, converts it to a string, and returns that. That's not true. Sorry, it's Python. I want actually Python 2 and not Python 3. Oh, perfect. This changes the game, right? Yeah. Equivalent of evil raw input. So it actually like executes the code which we pass to it. So what we are supposed to actually print the flag. Well, this shouldn't be too hard, right? Can we do just like print flag? Let's see if it works. Print flag. No, it doesn't. Well, that's not good. So let's try something else. Let's try. Do we have sys access? We probably don't. But we. So yeah, let's try this. Like sys std out. Right. And what flag? And it says sys is not defined, but that's okay. We can use a funny trick. So I don't know if you know, but in Python, right, there is this import sys. But you can achieve exactly the same stuff if you do sys equals import sys. It returns the module for you. Therefore, what you can do is you can do import sys, and it returns the module, so we can do standard output dot write flag and see if this. Yeah, it works. Eval is best thing ever. Actually, on my blog, again, if we go to /n, the notes, and there's something like called Python sandbox escape here. And there are some notes on previous challenges on sandbox escaping in Python. It's actually one of my favorite categories on CTF, so I really like it. So let's go to Python eval 2 and solve it. So we solved this. Now, again, input. And, sorry, is this the task already? No, this is the task. We can do it here, so we need to connect to another location. So let's do a reset. And we have to guess some 5-digit code, which obviously is not what we are going to do. If we guess it, print pegs, what print pegs? Prints something, print. When it does something, and you get it right. Oh, but we need to print the flag. So again, we do need to print the flag. So can we use the same trick actually? Yes, we can use the same trick. So okay, mastermind. So that was easy. Python eval 3 then? Is there Python eval 3? Yes, there is. Let's do it. Sorry, the page reloaded. I need to find it again. So print flag wouldn't work because print doesn't. Oh, maybe it will. That's true. Let's see. No, because print is actually a keyword in Python 2. In Python 3 it's a function, but this is Python 2 and it's a keyword, so it acts differently. Okay, and now this is task 3. Where is the task 3? Here we need to go to yet another different location. So I'm going to reset the console again. It works, perfect. So it's going on here. It shows us the menu, which it does, and then input again, but it removes. Oh my god. Okay, so they want to play, hey? They removed import, but again, what I do on the CTFs, I go here because you can get back the import if you go deep enough into classes. I actually do have some slides which explain it, so let me see if I can find it really fast. Oh, I know where I should have some slides. Okay, this is the conference which we did, and there are the presentations to download, and I have a presentation called Python in a hacker's toolbox. Actually, if you look for it, the old version is available in English on YouTube. Blah blah blah. Not interesting at all. This is not yet it. This is it, yes. Okay, yeah. So this is the idea. You start with, I hope you can see the slides. Well, I cannot like, can I go full screen? Let's go full screen. Yeah, okay. Well, my face is covering part of it, so I'm going to turn off my face for a few seconds. Anyway, and I'm going to actually turn off this as well. Yeah. So you start with this. You start with this is a dictionary, right? And in the box below it, it shows what there on the formula on this is the formula what it displays, and it displays all the fields which are related to it, because in Python is like really rich in terms of introspection, and this is actually what is the evaluation of a formula. So a dict is just a dict, but it has something called like a field called class. And wow, this doesn't work really well, but okay, yeah, whatever. If you go deeper into it, then it actually has a hidden field called base, and if you go into the base, it's the base class, but so it's like this. Dict is a class, and every class in Python actually inherits over a type called object, of this type, object, right? Every type. And this object type has something called subclasses. So if every class inherits over object, then all classes in Python are actually subclasses of this. So therefore, this gives you a list of all the classes which are in the environment. And as you can see, it's actually a function, so we need to call it, right? And then these are all the classes which are in the environment. And there is one class called warnings, catch warnings, which is quite interesting. And it's interesting because So you actually need, you know, index it to get to it. Then you create an object of this class, if I remember correctly, and it has a field called module. Now, module is actually this module called warnings Python, and actually all the warnings, all the modules in Python have something called built-ins, and built-ins is actually the global functions, global environment of that. And surprisingly, like, import is also on the built-in. So yeah, so this is how we get back to this is how we get back to having the import keyword, and once you have it, well, that solves a lot of problems. So let's just start with this. Sorry, I'm probably going to need to these are my old nodes, but I need to copy my exploit. And the number here, the 59, it actually changes, but that doesn't matter, I can just brute force it. So built-ins, and then I do import. So exactly this. Okay, now I guess I can show myself again to you guys. Hello. And having this, let me maybe extend the window. I can do again sys, and you know the drill, right? Std out and write. What do we write out? We write out the flag, right? Is it called flag again? No, it's not called the flag, but we can actually use it to test. Let's use it to test, and we can print anything actually. Let's just print AAA to know that it works, that we found the correct number here, because this number is kind of unknown to us. It crashed because import is not found, so that means we got the number wrong. Okay, so here it says it may be 49. It depends really on the Python version, on the environment, on a lot of factors. So that doesn't work either. So the best way to go around is, you know, to try all different numbers, but okay, that's not it. I should probably like automatize this in some way. Yeah, let's do it like smartly. How do we do it smartly? Let's write a stupid script to do it smartly. How do you like that? So let's change this to quotes, and this is a string now, and this is actually a number here. I'm pretty sure the number is going to be like above 10, and I'm going to call it format. Now, for I in range of 10 to, let's say, 60, I would like to do the following. I'm going to open a file called cmd.txt for writing, and I'm going to put the command var. This actually will emplace the number here, right? It's like standard printf. And I'm going to close it, and then I'm going to import OS. I'm going to do a system call. It's probably not the best way to do it, but it doesn't matter. And I'm going to call this. I need like a new line characters here as well. And I'm going to call this, but redirect the cmd.exe input here. Yeah, and let's run it. Let's see what happens. Crashes a lot, but doesn't display the... I would actually like it to display me the... Let's see if it works, if it prints AAA at any point. No, it doesn't, which is not good. I'd prefer it to display me the errors, actually. Why doesn't it display the errors? So I'm going to change this to standard error. Oh, I don't know if the standard error is actually redirected, so I can do that. Just to be like this. I can also test if this works actually, you know, on my local Python. So if I do Python, if it works at any point. Seems it did work at some point. There were quite a lot of errors, but it did work at some point, which is good. I'm going to add new lines here, and I'm going to actually let's do it like this. Quite a lot of A's because I don't know in what mode is there standard output, but there are basically two modes of standard output. It's either connected to a terminal or it's not connected to a terminal, it's connected to some pipe. In the first mode, the \n flashes the output, and in the second mode, I'm not sure it flashes the output, but I'm pretty sure the output is flashed after so many characters anyway. So yeah, so this should work, and I'm going to change this again to the netcut. No, not this place. Wait. What's wrong? That's my bad. Let's kill it. Kill it with fire. Yeah. Okay, so the question is the port correct? That's a good question. What's the port? Is it? No, no. The port is incorrect. Thank you. Props to KrzaQ for telling me that the port is incorrect. Now let's see if it works. This is incorrect, obviously. This should be like two backslashes. And yeah, let's run it again. I don't like that it's not displaying me the errors. That probably means that standard error is actually not redirected. Let's see if it's not redirected. No, it is redirected. Okay, screw netcut. We're going with sockets then. I actually have some boilerplate code which I usually use on CTFs. It's called Pwnbase. I'm just going to copy paste it here because why not? And it needs a port. So this is the host. This will be the port, which is 6363. Now I need to move it to my, here. Okay, but no. Go is going to take. So it doesn't do anything smart. It just connects to the port, and so I have a socket which is connected there, and then I can write to the socket. Actually, it's called send all. I can send my format with one enter at the end, and I'm going to run range of 10 to let's do 70 to let's test all the ranges because why not? And I guess I'm going to do something print. Okay. Wait. No. Yeah. This is a neat little trick, by the way. It basically connects the socket to a telnet lib library, which means you can actually interact with a socket by typing on the keyboard and whatnot. Exactly what you guys told me with. Okay, so this doesn't seem to work. Let's increase the range, but there seem to be like quite a lot of modules actually there. So I'm going to increase it to 100. No, it's indexed out of range, so that's not good. So, what do we do now? It's maybe because we did this, but no, it should still work for our modules. It's a good question. It's probably going to be the last challenge I'm going to solve today, sadly. Oh, what does this do? Maybe I should read the code a little more. It grabs a... That's fine, it grabs the files, a file, and it opens the file and reads it. Do I need to read? What do I need to read? I need to read probably the... So yeah, I can reuse this. That's fine as well. So Python is nice enough to actually be able... I will be able to access this open. I can just access the open actually. I don't have to do anything funky. No. Can I just do this? Read. And no file called flag. Maybe it's flag called .txt. No. Okay. So I guess it's not the... I don't have to find the flag. Is there a flag even there? It's not defined. Where is the flag in this task? I don't know. Let's try this. No. No. And no. How do I list directories? Can I list directories here? Probably no, but what I can do is, can I open bash history? How's this file called, by the way? No, that's good. That's a good name. Oh, okay. Okay. So, what can we do from path? Let's see what we can do from here. Path is a module. Does it have built-ins? That's a good question. Okay, the module actually should, right? Yeah, it does. Does it have import? No, it doesn't. Yes, it does. Okay, let's see if it works there. So it seems they removed like the import, they removed from everything. That's pretty neat. So what do we do now if we cannot do that? That's a good question. What does the path module actually have? Because we probably need to list the files anyway. I know at least one idea how to do it, but that's hardcore as hell. So does really does path? So KrzaQ says that path should have like .sys. Really does it? Oh, my bad. That's actually my bad. Really? It has OS as well? I didn't know that. Thank you. Yeah, okay. Yeah, I didn't know Path has OS. That changes the game, I guess, a little. Perfect. That means I learned another thing today, which is good. So KrzaQ, actually you just earned 110 points. Thank you. Let's do one more challenge, actually. But this one easier, okay? And then we can wrap it up. So we could do another Python evil. Is there another Python evil? Oh, there are quite a lot of them. So maybe another time. Let's leave them. Is there... What do we want? Nafsat. Let's see what this one is. Near the sun, you find a malfunctioning warp beacon, which is broadcasting a distress signal, blah blah blah. Damaged by... and there is data. Have been corrupted. The data has been corrupted and we have to recover it, so let's see. How do we go about that? Okay, so I'm going to leave this open. I'm going to just reset it. And this one is the recovery file, so let's just unzip it. And I cannot unzip it, which means the zip is broken. But so I can actually open the PDF with Total Commander. So I'm going to open the PDF in Total Commander because why not? And the PDF looks like this. It's a chart. But apart from the PDF, if I do, can I do zip info on it? There's actually another file called key, which is stored, which means it's not compressed. So I can do strings on it, and it should be okay enough. No. Let's do it properly. I'm going to open it in the hex editor. And this is, yeah, so this is here. Done. Okay. Yeah, basically if it's stored and is not compressed, then it's plain text. And therefore you can just find this, the name of the file in the hex editor, and then this is after the name of the file, there is the content of the file, which is, yeah, next stop. Tower ID. Then one more challenge, and then the name of. This stuff is too addictive. Ooh, spam carver. While exploring an alien tomb, you find an ancient JPEG of ancient cam of spam. It seems blah blah blah. So perhaps there's something more. Maybe it's cursed or hexed. It's hexed. That's a nice one. I love it. So, okay. Let's see what we can do with it. Do I need to... Oh, it's here. Well, it is hexed, like it's a can of a can. Huh. So what do you do with JPEGs? You copy the link and you look for exif. And there's a link to regex.info to Jeffrey's exif viewer, basically. And it tells you stuff about it. Is there any... So there's a question from Tori or Turi. Is there any reason I don't use spawn tools? No, not really. I just don't have them installed on this setup. That's the only reason. Otherwise, I'd probably use some of them. I also don't have PEDA here for GDB and so on. I also don't use them too much, that being said, because I have my own set of tools. But, like, spawn tools are way better. So there is absolutely nothing interesting in exif, therefore I just need to download it and see what's up. With, you know, old school hex editor, so downloading it. And let's start with viewing it in viewer. This is a viewer. There are some spaces here, so there seem to be some comment, but they carved it out. And let's see what's at the end of the file. So, okay, there's something added at the end of the file, because every JPEG should end with an end of image marker. If you go to Wikipedia and JFIF, I think it's in JFIF form, which is like file interchange format, they tell you that there's something called end of image, and that at the end of every file there should be ffd9. Now, as you can see, I don't know if you can see it, but this is not ffd9, it's 00. But there's pk, and pk is usually a zip, which means, so it's actually quite funny because you don't parse the zip file from the beginning. You parse all the format files other than zip, almost all. Almost. But most of them you parse from the beginning of a file. Now zip you parse from the end of a file, which means you can concatenate almost every file format with a zip at the end, and it will still be a valid file. So I'm going to change the name of this to, I'm going to rename it to a zip file, and I'm going to launch a console again. No, actually I'm going to launch a Linux console. Okay. So this is already renamed it, and let's do unzip. Okay, do I want to process it? Yes, I want to process it. Sorry, I absolutely don't understand what's going on here. So I'm going to spam carver to xxx, and one more time. Unzip it. Extra bytes at the beginning. Do I want to replace something? I can replace something, why not? And it's a directory. Probably somebody removed the name of a file, whatever that was. So I'm going to open the file in a hex editor, and this hex editor is actually really cool because it has something called a structure viewer, and you can select as a library name, and it has zip format. So I just open this, I go to the end of the file, and here I know that at the end of a zip file there is something called an end of central directory header. So I'm going to add it here, add structure, end of central directory header. Then I know that it tells me that there's a file somewhere here, this pk0102, that's actually an entry in the that's an entry in the central directory. So I actually know the zip format quite well. So if you don't know the zip format, just read about it. It's actually super easy. It's surprisingly easy. Unless you start getting into how the compression works, the rest of the zip is quite easy. And it actually even marks, you probably see here with this green checkbox, that according to its analysis, this is really a central directory entry. And now I can read it here. Is there something interesting? The interesting part is here, which you can see. It's basically the name of a file is empty. It's supposed to be 8 bytes long, but it's empty. Therefore, why is it empty? Because there are spaces here. So I'm going to replace the spaces with something else. I'm going to replace it with AAAAA, and I'm going to save it. And then these spaces are probably, because the name of the file are actually in two places in the zip file, in the central directory and also in something called the file header, which is next to the file. So I need to look for the file, or I just look for the pk letters, because every header in a zip file begins with pk letters, so I need to look for it. I'm going to use Ctrl F. Not hex first. PK. Match case, and we look up. Okay. How do I repeat the search? Is it F3? Is it Ctrl F3? No, come on. How do you look for it? Okay. Find all. Where's the find all? No. Find all instances. It should actually display me a. Well, whatever. I'm going to scroll up. It probably highlighted it, so I'm going to notice it. Scroll. Wait. Here. Is this? Yeah, it's probably a correct. This is a correct magic. It's pk and then 03 or 4. Therefore, I can again add a structure and add. This is a local file header. It also highlighted me that it's a correct local file header. And again, there's something like a file name. Can you see this? Yes, you can see this. And it's again empty, and it's here. So I'm going to replace it with AAA again. AAA, and I'm going to write this file, and now I'm going to try to unzip it. But I actually use it, the one in the upper directory. So I needed to copy it. And now I have AAA. What's this? Is it? It's a JPEG image. Okay, so another JPEG. So I'm going to change the name to JPEG. And this is what it looks like. Oh, okay. So yeah, okay, that's it. I'm not reading it though. Yeah. GOCR is like an OCR, but it did destroy some of the letters, so I need to type it manually anyway. Crap. Okay. 7E. This is okay. 3A, 7BA, 9, and this is 9, and this is O. Okay. So yeah, that was an OCR, which tries to get a text from the image. GOCR it's called. And I now can put it here, and let's see if it worked. It worked! Perfect! So yeah, that's it. Just fixing a zip file, well, the name and the zip file, so that was rather easy. If you know the zip file again, because, well, again, I know a zip file, I like that format quite a lot, so it helped. Actually, it helped. So yeah, so that's actually it for today. If you have any questions or any comments, like put them in the comments under the video when it's on YouTube. It should be quite soon. And that's it actually. So thank you very much for watching. If you would like to have the second part of picoCTF, where I would solve all the unsolved challenges, or most of them actually, because they will take more and more time, then let me know in the on the chat or in the comments under the video, and I will record it as well, maybe next week even. So that's it. So again, thank you very much for coming and watching my stream. Again, thank you to this guy, for KrzaQ, for being my moderator today. And I'm going to answer one more question. What kind of music do I listen during the CTFs? I usually listen to what I'm about to turn on right now, which is Nervous Test Pilot. I actually really like his music. It doesn't have vocals, so I don't sing along, which means I don't annoy my wife. Therefore, and it's quite easy to focus with. Or Iron Maiden. Depends on my, my mood, basically. So that's it. Thank you very much, and see you on the next stream. Bye-bye.